Hey guys, and today we'll talk about thermophysics. Let's start off with temperature and heat. Temperature can be defined as the number which expresses the hotness or coldness of a body on a defined scale. It can also be as the hotness or coldness of a body or place. On the other hand, heat is the form of energy that can be transmitted through different states of matter, from a hotter region to a colder region. The instrument used to measure temperature is called a thermometer, and there are various types of thermometers. The SI units for temperature is Kelvin. However, temperature can also be measured in degrees Fahrenheit or degrees Celsius. Let's discuss the upper fixed point. The upper fixed point refers to the boiling point of pure water being boiled under standard atmospheric pressure, which is 760 millimeters per mercury, or 1 atmosphere, or 10 power 5 pascals. Please note that Hg is mercury. Now, the lower fixed point is the melting point of ice of pure water at standard atmospheric pressure, which is 1 atmosphere. Now, the interval between the lower fixed point and the upper fixed point is called the fundamental temperature interval. Now, let's discuss the Kelvin scale. The Kelvin scale is used in the International System of Units, and the temperature in this scale is measured in Kelvin. Let's look at the relationship between Kelvin and Celsius. If the temperature on the Celsius scale is 0 degrees Celsius, then on the Kelvin scale, the temperature is given by T equals to degrees Celsius plus 273. Let's move on to the relationship between Celsius scale and the Fahrenheit scale. When given temperature in degrees Celsius and required to convert to degrees Fahrenheit, we use the following formula. Degrees Celsius equals to 9 over 5 into F minus 32. Don't forget, 9 over 5 into F minus 32. We can use the above formula to find what we want by making it the subject. For example, turning Kelvin into Celsius, Celsius into Kelvin, and so on and so forth. Now, I assume you all know the three basic states of matter: solids, liquids, and gas. Now, I want us to talk about the properties, the arrangement of particles, the distance between particles, the attractive forces, the motion of particles in each of these states. Let's start with the properties of solids. For solids have a fixed shape, they don't flow, they have a fixed volume. And the arrangement of particles is they have a regular fixed arrangement. And for the distance between particles, the particles are packed tightly close together. And the forces of attraction are very strong. And the particles vibrate about a fixed point. Now let's move on to liquids. Liquids take the shape of a container, they flow, and they have a fixed volume. The particles have a random arrangement. The distance between particles the particles are close together but are not packed like that in solids. And liquids have weak forces of attraction. The particles rotate and change location. Now let's move on to gases. Gases fill the container, they flow, they don't have a fixed volume, they have no set arrangement in the particles are very far apart, the forces of attraction are negligible, and they move at very high speed. Let's move on to heat transfer. Now, first of all, heat is a form of energy that can be transmitted through different states of matter. Transmission is effected either by one or more than one of the following methods. Number one is conduction. Conduction is the transfer of heat without the bulk movement in the molecules. It can be demonstrated by holding a metal rod on one end while the other end is exposed to fire. Now, after a little while, you'll notice that the end that you're holding with your hand is starting to get hot. Now, this is possible because the heat is being transferred by conduction. The second method is convection. Convection is the transfer of heat through matter by the movement of the fluid itself. This makes molecules move in what we call convection currents. Convection currents can be visualized in fluids. Now, convection currents can be demonstrated in gases when you use a smoke chamber. It should be noted that convection only occurs in fluids, that is, liquids and gases. We see convection currents in everyday life, such as in chimneys, ventilation, land and sea breezes, car cooling systems, and wind movements. The next method is radiation. Consider the following situation I'm about to mention in everyday life. Number one, a person seated near a fire. Rays from the sun feel hot. Now, from these two scenarios, heat is transferred by a process known as radiation. Radiation is defined as the transfer of heat of invisible rays, known as electromagnetic waves, through medium, meaning transparent medium such as air. Therefore, heat can be transferred to three basic ways. Number one, conduction. Number two, convection. And three is radiation.